We are going to see one video lecture for the subject Theory of Computation, and the topic is Deterministic Finite Automata from the first unit. And the objectives are to understand the concepts of DFA and to analyze the problems on DFA. Let us see the definition of DFA, Deterministic Finite Automata. In the previous videos, we have seen the definition and the concepts of finite automata. Deterministic finite automata means it has the uniqueness in computation. All the states are determined and the machine will goes to one state only for a particular input character. And another one thing is the system will not perform the state transition without consuming any input symbol. And the DFA system can be represented with the help of two methods. First one is transition diagram, second one is transition table. Let us see how to draw the transition diagram. The transition diagram will have the directed graph model with the vertices of a graph corresponds to the states. So we will mention each state of the system with the help of the vertex, that is a small circle. So in this example we are having three states Q0, Q1 and Q2, and the edges in between the states will have the label input symbol. For example, in our diagram Q1, Q0 is changes to new state Q1 by consuming the input symbol 0. And in our example we are having three states Q0, Q1 and Q2. Q2 is the final state. So to mention the final state we have to draw the double lined circle. And in the DFA definition, capital letter Q is the set of states and delta is the state transition function. Delta will have the two parameters, that is the current state and the symbol. For example, del of Q comma A equal to P. The meaning is Q is the current state. The state will consume an input symbol A and the state is moving to the new state. The system is moving to the new state P. And the next form of representation is tabular format. In the tabular form, row wise we have to represent the states of the system like Q0, Q1, Q2. Column wise we have to put the input symbols. So for the corresponding diagram, we are having the table. In the table itself we can understand Q0 is the state. Q0 will consume A and it changes to the new state Q1. And Q0 when it takes the input symbol B, it is remains in the same state Q0. So in the diagram we are having the self loop on Q0 with the input symbol B, and the Q1 is consuming input symbol B and it is moving to the final state Q2. So in this way we have to represent the DFA with the help of the diagram and table. And now we can see the formal definition of DFA. DFA can be defined with the help of 5 tuples. First one is like capital letter A equal to Q comma capital letter Q comma sigma comma delta comma Q0 comma F, capital letter F. Here first element is a finite set of states, capital letter Q. Second one is sigma will represent a set of input symbols. Third one is delta is transition function. Transition function will represent how a state change is performed, how a system is changing from one state to another state. So the arguments of the state transition function is a state and input symbol, and it will return a new state. And the Q0 is the starting state, which is one among the state one among capital letter Q, and capital letter F is set of final states. Now we can see the example problems for constructing DFA. The first example is construct DFA that accept the input string of zeros and ones, and the condition is the string should end with 1 1 or 0 0. We can draw the diagram for the first condition, that is the input string have any number of zeros and ones, and the condition is the string should end with 1 1. So first of all we should decide how many states, minimum number of states are needed to construct this DFA. So to identify the minimum number of states, we should consider the basic string. So in our problem, basic string is 1 1, and other strings may be like 0 1 1. Other strings may be have any number, any length, like 0 1 1 1 1 1 1 0 1 1, etc. So basic string having 2 digits, 2 characters, 1 1. So our number of states will be 2 plus 1 equal to 3. So to construct the DFA for this condition, we may need minimum 3 states. So we have to put, initially we have to simply put states Q0, Q1, Q2. And Q0 is our starting state, Q2 is our final state. So Q2 will be put inside a double lined circle. Q2 is our final state. And we can connect the states. When we connect Q0, Q1 and Q2, we may have 2 edges. So the first, we should put input symbol 1 for the first edge, and again in the basic string we are having 2 characters 1 1, and in the second edge, that is edge from Q1 to Q2, should also be labeled with 1. So we have drawn the diagram for the basic string 1 1. Then we have to apply all possible strings. Then, and another one important thing is, every state should have 2 arcs, 2 emerging arcs, since our set of input symbols will be, our input symbols will be 0 and 1. We are having 2 input symbols, zeros and 1. So from every state we should have 2 arcs, one for 0 and one for 1. So from Q0 to Q1 already we had the edge with 1. Then we should have one more edge, one more arc from Q0. So no other possible options. So we can have the self loop in Q0 with the input symbol 0. Similarly, from Q1 we had one arc with the label 1 to Q2, and we have to put one more arc with the input symbol 0. So we can have the arc from Q1 to Q0 with the label 0. Similarly, Q2 is the final state, and Q2 should have 2 arcs, one with 1, another one with 0, and we can imagine any number of strings with our condition. So our condition is our string should end with 1 1. So in the Q2 we can have the self loop with 1. So when we imagine the string, in any cases the string is ending with 1 1, like 0 0 1 1 1 1, it is going like 1 1 1. So we can have the self loop on Q2 with 1, and Q2 have one more arc, have to get one more arc with 0. So we can connect Q2 to Q0 with the label 0. So the condition is, first condition is, we should determine the number of states. It is based upon the number of characters in the basic string. Then we should consider the number of symbols. In our example we are having 2 symbols, zeros and 1. So based upon the symbols we should have the number of arcs from each and every states. So by putting in any way we can draw the connectivity edges, but in every cases we have to check whether we are satisfying our condition. And this is another one example. In this example, the problem is the DFA should accept all the strings of zeros and ones. Here also the input symbols are 0 and 1, and our string should have sequence of 0 1 in somewhere. That is, we can have the string with zeros and 1 in any length, but the condition is we should have this sequence 0 1 sequence in somewhere in our string. So we can write the language of this particular string, particular DFA, as x0 1 y. X will be any 0 1 x is the substring, can have any 0 1 combination. Y is the substring, can have any zeros and ones. In the middle or in somewhere we should have 0 1. So for this condition we can draw the DFA. So this is the corresponding transition table. In the transition table we should identify what is happening, that is Q0. When 0 is applied to Q0 we are getting the new state Q1, and I can tell you another one example. When apply 1 to Q2 it remains in the same state Q2. In this way we have to draw the transition table. And finally for every problem we have to define DFA in the formal definition. So in this problem, formal definition means we have to write the number of tuples like set of states, set of input symbols, delta, starting state, final state. So for this problem we can write set of states Q0, Q1, Q2, set of input symbols 0, 1. Transition function should be mentioned with del only. Then Q0 is the starting state, Q2 is the final state. And we are having some more examples, that is DFA for strings having that can contain zeros and ones and end in 0 0 and so on. And the problems like DFA, to construct the DFA for the string ending with ABB we have to follow the same rule. Basic string is ABB, means we may need 4 states to construct the DFA, and the condition is from every state we should have 2 arcs. Since our input symbols are 2, A and B, we should have the 2 arcs from each and every state. In any way we can connect the states, but at any situations we have to check for our condition, that is whether the string is ending with ABB. And this problem is DFA to accept the strings that should end with AB. And similarly we are having many examples. You can refer the website notes for different examples. And the possible university questions are we can have many problems on DFA, that is to construct the, we may asked with some conditions, and we have to construct the DFA for some strings. Then theoretically we can have the question like explain the deterministic finite automata with example. Thank you.